Hello, David here, and welcome to this tutorial, where you will learn how to add and remove parts from an assembly in Visual Components. When following any tutorial, check the lesson on the Visual Components Academy, and if the Download Files option appears, you can download the example files. We begin in the Home tab, where in this layout we have 4 products: a pallet, a box, a pack of chips, and a can. And going to the Process tab and clicking on Products in the ribbon above to enable the product type editor, we have a EuroPallet assembly product type we created earlier. It has an assembly product type name, and expanding the tree, we see the first main assembly step, which is the EuroPallet. Then the boxes with the chips and the cans that are placed inside the box. Selecting the EuroPallet assembly product type and clicking on the pen icon opens the assembly editor. If we use the Select tool to select a chips assembly slot in the assembly editor and check its properties over on the right, we can see from the order index that this is the first product to enter this slot, and the other chips is the second. And if we check the product filters and the product type filter and its accepted product types, it's only chips that is accepted here in this slot. And if we click on the can step on the left and select a can from this assembly slot, in the product filters and the product type filter, the accepted product types is can, and this is the same for all the cans. This product filter was applied to the first can product type, and when we used an add slots pattern to create the rest of the cans, the same product filter was applied to all the cans. And note that if we wanted to later change the product filter for any of the product types inside this slot, we would need to modify each product individually. So then closing the assembly editor, using the control on the right, and returning to our layout and selecting the eCatalog tab and browsing for conveyors, and then Visual Components conveyors. Then selecting the PNP tool above, drag and drop a conveyor into our layout, and then go to PM Flow Components and drag and drop in a feeder, and connect it to the conveyor using PNP. And with the feeder selected, in the Product Creator tab of its properties, set the part to be the EuroPallet assembly product type. Then press play to run the simulation. And now we see the EuroPallet assembly we just reviewed is being created. Then resetting the simulation, what we now need to do is select the conveyor, and from the default tab of its properties, change the preset to a roll conveyor and set the width to 1 meter and the length to 2 meters. Then press play to run the simulation, and now things look a bit better. Then resetting the simulation, another way to create an assembly is to use a process node. So we will select the feeder and delete it. And again from PM Flow Components, drag and drop a process node and connect it to the conveyor using PNP, and check that the correct interface is connected, which is here the beginning point. And then enabling processes in the ribbon above, click on the process node process label to open the process executor panel, and double-clicking on the panel label, rename this process to pallet feeder. Then selecting the transport in statement from statements, add a create statement, which will appear below, and then delete the transport in statement. Then selecting the create statement, set the product type to EuroPallet assembly, which will create the pallet. And when the program distinguishes that this is an assembly, it will automatically list all the assembly steps. Then apply a local product variable name palette. We should try and use a good naming convention for these variable names, although we could just use any variable name within this specific process since these variables are local. Then select the transport out statement. Again, palette will be the local product variable name, and set the destination to component container. We can now press play to run the simulation, and we see that our assembly is being created, but of course this doesn't look correct. So then, resetting the simulation, we can add a delay statement after the transport out statement and set the distribution of parts to be every 200 seconds. And pressing play to run the simulation, we see that a single pallet is created with all the components in it. Then resetting the simulation and returning to the create statement inside the pallet feeder process and expanding the assembly steps in the properties on the right, let's say we first want to use a process to remove the chips from the pallet and then later add the cans. So we will first create the pallet with the chips, but without the cans. So click the bin icon to remove the cans. And pressing play to run the simulation, we see the pallet being created without the cans. Then resetting the simulation and closing the pallet feeder process executor panel, from the eCatalog, we will drag and drop another process node and using the PNP tool, attach it here on the other end of the conveyor, and the interface will be connected at the center point. Then click on the label to open its process executor panel and rename the process to remove chips. And then selecting the transport in statement, we transport in any product from source from component container and set the local variable product variable name as pallet. And note that the local variable name for the assembly here in this remove chips process is different than what we have over here in the pallet feeder process. And then selecting the transport out statement, at the end we transport out with product variable name pallet and with destination to component container. And the magic then happens between these two statements. So now selecting the transport in statement, from statements add a getAssembly statement. GetAssembly creates an assembly order object. The assembly order defines or selects the subsequent assembly steps from an assembly product type. So the order here we want to remove is from the assembly data source assembly product type. The assembly data source includes two types. One is the assembly instance or the whole assembly product type, and we can get access to both. And if we select the assembly instance, we can get access to the assembly step based on these options. So we can get access to the first incomplete step, the first empty step, the first complete step, or the last step with products. For example, if we want to remove parts from a pallet, then we would access the last step with products. Right now we just want to remove the chips from this pallet. So what we would do is set the assembly data source to access the assembly product type. Then select the assembly to be our EuroPallet assembly. And to get access to the chip step from assembly steps, remove all steps except for the chips. And the return variable name is assembly order. But what we could do is just name it as assembly order chips. We will later add more statements to this process, but for now we can close this process executor panel and open it again later when we are in the flow editor view. We will then remove the chips to a sync process, which we can add from the eCatalog. And this sync process is an area the removed chips will be dropped to. Then click on Flow from the ribbon above to open the Flow Editor. And in the Process Flow Editor below, we have the Euro palette, which includes the assembly product type and also the part product types. There is another flow group with a VC cylinder product type here. This was created when we earlier added the feeder from the eCatalog. When we deleted the feeder, these product types remained, which we can also see from the product type editor. We can right-click and delete these either from the product type editor or here from the process flow editor. So then, selecting the Euro palette flow group so that it's highlighted, left-click on the label of the Remove Chips process. It will be added to the flow. Then move the cursor over to the center of the sync process. It will be highlighted in yellow and a blue transport link connection to the process will appear. Then left-click on the sync label. The transport link is created and the sync label will be added to the flow. Now we want to reopen the Remove Chips process executor panel. And when the flow editor is enabled, the process labels don't appear in the 3D world unless we place our cursor over a process. And in this view, we wish to prevent any unintentional flow step creation by left-clicking on a process label, which might then add it to our flow. In this example, by left-clicking again on the label of the Remove Chips process, we will add a flow step we do not wish to create, and then just select the step handle and delete the unwanted step. Note that when we remove an unwanted step, any transport links that we created may also need to be deleted separately. Selecting the transport link in the flow editor will highlight in yellow that transport link in the 3D world, allowing us to identify which transport link we can delete. And to prevent any unintentional flow step creation, we can only right-click on the label to open the process in this flow editor view. And overall, when setting up our processes, it is recommended to use the processes view, and then enable the flow editor once we are ready to set up our flow. So now in the flow editor view, we can right-click on the label to open the Remove Chips process. So now the palette arrives, then we get access to the chips product, and then we would need to transport out the chips. So then selecting the Get Assembly statement, we will add another transport out statement below it. And in the properties, we need to specify the product variable name and the mode. Right now we want to transport out multiple assembly slots. So the product variable name is palette. And we would select the mode as process and assembly. And we want to remove the assembly order variable name of assembly order chips, which we defined in the Get Assembly statement above. And the destination will be to next process, which is the sync process. And then in the transport out statement below, we transport the palette out with destination to component container. And pressing play to run the simulation, and we could increase the simulation speed to 2 times faster. So the palette arrives in this process, and then both chips products are removed. Then resetting the simulation, now we can close the Remove Chips panel. In the next step, which will be on another conveyor, we want to add the cans. So then selecting the conveyor, using the PNP tool, we can clone it, and it's automatically attached to the first conveyor. Then delete the copy of the Remove Chips process, and from the eCatalog, add a new process node, and attach it to the conveyor in the same way as before, so we can have a process for adding the cans. Let's return to the Processes view to set up our new processes, and click on the label of this new process node, and rename it to Add Cans. So what is the purpose here? Selecting the transport in statement, we want to import from source from component container. And having the source as from component container means that this process can only accept products coming in from the conveyor. So we don't necessarily need to use a product filter here. And then add product variable name palette. Then we will add a getAssembly statement here with assembly data source, assembly product type, where the assembly is the EuroPallet assembly. And we want to bring in the cans. So in assembly steps, we remove all other products except the cans, and with a return variable name, assembly order cans. And to import the cans, we add another transport in statement here, below the getAssembly statement. We set the mode to process an assembly with assembly variable name palette, and we are importing the cans using assembly order variable name assembly order cans, and with source from previous process. And what will be the product variable name for these cans when they arrive? It could be, for example, arrived cans. And then selecting the transport out statement. After that, when the cans are received, we transport out with product variable name palette and with destination to component container. Then closing this process executor panel, we can add another process node from the eCatalog. And clicking on its label, rename it as Can Feeder. And to create cans in this feeder, selecting the transport in statement, add a create statement. And delete the transport in statement, and then selecting the create statement, set the product type to can, and the product variable name to product in. And when the can is created, we send it to transport out with the same product variable name product in, and send it with destination to next process. And now we are ready to add more processes to the flow. So let's close this panel and return to the flow editor view. Then selecting the handle of the last process in the current flow, left click on the label of the can feeder process, it will be added to the flow. Then move the cursor over to the center of the add cans process. It will be highlighted in yellow and a blue transport link connection to the process will appear. Then click on the add cans label. The transport link is created and the add cans label will be added to the flow. Okay, so now let's click play to test the simulation and increase the speed to, for example, 10. The chips packs are removed and then the cans are being received based on their availability from this process over here, can feeder. And then we wait for some more time because this process pallet feeder includes a delay of 200 seconds, and then the next pallet is created. Right now the cans are coming in based on their index order. Then resetting the simulation, if we return to the product type editor and select the EuroPallet assembly and open the assembly editor, and using the select tool, these cans have an order index of 4, 5, and 6. And switching to the top view might help with this selection. Click and drag to select these 3 cans and edit the order index for all to be 4. This can with order index 1 will be the first can product to enter, then 2 and 3. And then these 3 cans with the same order index will enter at the same time, and in all cases based on product availability. Then closing the assembly editor, and in the processes view, opening the can feeder process, the statements here, Every time it is possible for them to perform a task, they are being executed right away. There is a can being created, and then it is transported out. And then right away, a can again will be created, so at the moment there is no delay. And that's why there will be parts available if there is a request on the other side for multiple cans. So let's click play to test the simulation, change the simulation speed to 5, and let's see what happens. So 3 cans are coming in, and then right away the next 3 cans will arrive together. Okay, so this is what we wanted to go through in this tutorial. And now you know how to add and remove parts from an assembly. And a quick final note, in the downloads for this lesson, we will include an image of all the process statements created during this lesson, which we hope will help to visualize how the processes work and relate to each other. And this concludes the lesson. Thank you for watching.